In this video, I'm going to show you how to create a simple single oscillator voice patch using this Eurorack system. I have MIDI data coming out of Ableton Live on this computer here, going into this MIDI to CV converter module. So I'm going to use two pieces of information from the MIDI world, the pitch information and gate information. Pitch is going to be used to control the pitch of the oscillator, and the gate is going to be used to control the volume of the sound. Now, typically on most oscillator modules, you will have a 1 volt per octave input, like on this Z3000, but on the VCO-6, it's labeled a bit differently. They call it FM exponential. In fact, there are two labels here, FM2 exponential, FM3 exponential. Both of them would work. And you can see here, there are the two inputs for those. All right, so let's set this up. I'm going to take CV1 from the MIDI to CV converter, which has the pitch information, and plug that into FM2 on the VCO-6. Now, if you want things to be perfectly in tune, you want to make sure that the knob is set all the way to the maximum. All right, now the VCO-6 has a bunch of waveform outputs. They're all labeled with the black background. So I'm going to take the third output here, which is a sawtooth, and I'm going to plug that into the filter, the multi-mode filter, MMF-1. It has two inputs, audio 1 and audio 2. I'll just plug it into audio 1. There is a level control for audio 1. I'm going to set that in the center. Most of these modules with level controls, if you go above that 12 o'clock position, they tend to oversaturate or distort the signal. All right, next I'm going to take the audio output from the filter and plug it into the audio input on the VCA. It's not labeled audio in on the VCA, but that is the audio in there. I'm going to leave the gain all the way down, and that's very important. We're going to control this with the ADSR. So let's take the gate output from our MIDI to CV module and plug that into the gate input on this ADSR here. Now, if I was to just send in some MIDI data, so I'm just playing on the virtual keyboard on this laptop here. We're not hearing anything yet because nothing is connected to the audio output, but you should notice that on the MIDI to CV converter module, as I'm playing different notes, that gate LED is lighting up. So we know that it is working. And also, if you keep an eye on the Quad ADSR, you'll notice that LEDs are lighting up on that one as well. One very interesting thing with this Quad ADSR is that even if you give one gate input, you can trigger all the 4 ADSRs simultaneously. So you notice we're just feeding this one gate signal over here, but all the 4 ADSRs are being triggered. Now, if I was to plug the gate to the second gate input on the second ADSR, you'll notice that we have now unlinked all the 4 ADSRs, and now the second ADSR is the only one that is triggered when I'm playing notes on the keyboard. All right, let's stick with this second one here. I'm going to take the output of this ADSR and plug it into the CV input on the VCA. I've set the CV amount to 12 o'clock. Again, going any higher may distort the signal, so I'm going to leave it there. All right, so that is pretty much the voice. Now we just have to listen to this. So now let's take the output of the VCA and we can plug it into the monitoring system. My monitoring system is going out on that 1/4 inch jack on the multiples. So I just need to take the output of the VCA and plug it into the input on the multiples. Now keep in mind this signal could be quite hot. So you may want to use an attenuator first to tone down the level of the signal, or use an external mixer to control the level. But if I play on the keyboard now, you should be able to hear the sound. We're currently hearing this ADSR in work. Let's talk a bit about what's happening with the ADSR. I'm going to set the attack all the way to the lowest, and I'm going to set the sustain to the highest. So this way, as soon as I play a note, you hear the sound immediately, and as soon as I let go, well, the sound does die out a little bit because I have a little bit of release there. With the ADSR, you will notice that there's a switch over here. It's labeled M, L, and H. Right now it's in this M state. So this defines the actual time length values for your attack, decay, and release. So if I was to set the attack somewhere at about the 4 mark, you can hear the attack time there. But if I switch this to L and then play a note, you notice that that attack time is much quicker. So think of this as a scaling device that will scale the values of all the time parameter knobs here, like attack, decay, and release. So in the medium state, you can hear some attack. If I set to the low state, it's very short. It is still there. It's like very, very short. And then at the bottom value, when it's set to high, it's extremely long. You can see it's taking forever to increase in level. And the same is being applied to the release. We have a really long release. Without release, the attack is still very, very long. So if you want really long, extended ADSR envelopes, you can set it to H mode. But typically, you're going to be using the standard M state, which is kind of like medium. Alright, so that's a little bit about the Quad ADSR module. In the next video, I'm going to continue with the same patch and show you features on the Cwejman VCO-6 oscillator. So stay tuned for that.